Algebra 1, Set 113, Functions. We're just going to look at a couple of relationships between variables. So if we have something that looks like y equals x plus 6, our input is x and our output is going to be y. So if we have an input like x equals 4, we plug 4 in, y equals 4 plus 6, so y equals 10. Our input was 4, our output is 10. If we have a number like 23, we plug 23 in, our input is 23, our output is 29. The value of y always depends on what the value of x is. So we call y a dependent variable because y depends on x, and we call x an independent variable because it doesn't depend on what y is. Now we'll look at what we call functions. So a function is a relationship between two sets in which the first set is the domain, and it is defined, so you have to make sure that you know what your input is. And secondly, for each member of the domain, there's exactly one answer in the second set. Okay? It's a little confusing, but we'll do several examples, so hopefully that will make more sense. So, for example, if we have y equals 4x plus 6, and we know the domain is the real numbers, we have our inputs. We know that we have domains, so the domain is the real numbers, so that would be our input. If we take one of those and plug it in, 4 times 2 plus 6, we get 14. 14 is our output. If we put 2 in, 14 is the only thing that's going to come out. We're not going to get any other numbers other than 14. If we plug 10 in, there's going to be one and only one answer for plugging 10 in. 4 times 10 plus 6 is 46. So, first of all, the domain is specified. We know that the domain is the real numbers. And secondly, for any value of the domain, the equation gives one and only one output for every y. For one and only one output, that is y. So, looking at this set of ordered pairs, is this a function? Is there a domain? Is it specified? And we can see yes, there is a domain specified. All of our inputs are 4, 5, 7, and 8. That's our input. Secondly, does x give one and only one y? So if I plug 4 in, do I get only one answer? If I plug 5 in, do I get only one answer? And so on. And in this case, yes, there are no repeats. So is it a function? Yes, it is a function. You don't need an equation to tell if something is a function or not. You can go just off of ordered pairs. Okay, so we'll talk about 3 words that are going to show up a lot: domain, image, and range. Your domain is all the possible values of x. So whatever x can be is your domain. Your image is the answer or value of y assigned to each value of x. So each specific input has an image or a specific output. And the range is the set of all the images or all the possible y's. So here's an input-output machine. If we input 4, we get 7 out. If we input 5, we get 2 out. If we input 6, we get 14 out. Our domain is 4, 5, and 6. Our range is 7, 2, and 14. And our images are the individual parts of the range. So for example, 7 is an image of 4. 2 is an image of 5, and 14 is an image of 6. Okay, so talking about ordered pairs. No two ordered pairs can have the same x with different y's. If that happens, it's not a function. So for example, we have 4 goes to 7, 5 goes to 2, and 6 goes to 4. Is this a function? Yes, there's one image per domain, and we have a specified domain, 4, 5, and 6, and we get one and only one output for each input. Okay, is this a function? If we plug in y, we get p out. If we plug in a, we get x out. If we plug in m, we can either get x or 5 out. So is that a function? No. M is mapping to more than one image. You can only map to one image. So since M is mapping to more than one image, it is not a function. Okay, is this a function? A maps to 5, 4 maps to 5, 7 maps to 11. This one is a little bit tricky. Yes, it is a function. Remember, the rule is that the input has to have exactly one output. So A will always map to 5, 4 will always map to 5, and 7 will always map to 11. The trouble comes when you have an input that maps to more than one output. But in this case, every input maps to only one output. So it's okay for two inputs to map to the same output. Is this a function? Your input is the real numbers, and you're going to put it through y equals x plus 2. For every input, is there one and only one output? For example, if I pick 5, will I get one and only one answer? If I pick 7, will I get one and only one answer for x? Or when I pick 7 for x, will I get one and only one answer? So that would be yes. We have a domain, and there's one y for every x. Is this a function? Okay, so the first thing I notice is I have the same input here, so that's kind of a red flag, because remember, whenever you have an input, you want one and only one output. So when I look here, 4 maps to 6, and then 4 maps to 5. It's kind of unpredictable. I don't know if I put in a 4, what am I going to get out? Not sure. So in that case, since 4 maps to more than one thing, it's not a function. Is this a function? I have my domain 4, 5, and 11, so there's not really any red flags here. So the domain checks out, and then does the domain check one outcome for every input? Yes. So is it a function? Yes. All right, now we're looking at a graph. Is this graph a function? So we ask the question, what's the domain? If I'm wondering what the x's can be, I can use just about any x. If x is 0, I'm going to get an answer. If x is 1, I'm going to get an answer. If x is 2, I can choose any of these values for x. And I can choose any of these values for x. And I can go in infinity either direction. So since the domain appears to be all real numbers, it looks like the domain checks out. Now, is there one output for every input? So if I input 1, I'm going to get one output, and that's on that line. If I input 4 or 5, I get a specific output. If I input -4, I get a specific output. If I input -10, I get a specific output, and so on. So one output for every input? Yes. So is this a function? Yes. Now, the question is this a function? So we have to figure out what's the domain, and in this case, the domain appears to be everything bigger than 1. So I don't have anything over in this area, so no x's are over here. So my domain is everything that's bigger than 1. Now for every input, do I have one and only one output? For every x, is there one and only one y? So let's take a look. If I let x equal 3, I actually end up with 2 answers. If I let x equal 6, I end up with 2 answers. So in this case, no, it's not a function because there are more than one output for each input. The last thing we need to talk about is what is a relation. So a relation is a pairing that matches each element of the domain with one or more images in the range. One or more is the key here. A function maps to only one output. A relation can map to more. So if we go back to this graph, is it a function? No. But is it a relation? Yes. And let's try another example. Is this a function? We have 6 mapping to 4 and to 8. So for our input, we have more than one output. So no. Is it a relation? Yes. You can have more than one output in a relation. And our last one, is this a function or a relation? So we have a domain, but what we need to know is for every input, is there one and only one output? Well, we have this number 5 here. There is no output for 5, so there's no function. And the same thing goes for a relation. We have no output, so it is not a relation either. For a function or a relation, you need an output with your input.